Okay, so we have a bunch of material to cover because I wanted to actually cover some of the basics, some of the background behind this. I do have a set of environments that I can spin up for people to actually try stuff in. It works best if you have a laptop, because if you don't, then you're just going to be watching my screen, which is fine too. I will give you a link that you can take down. So there is actually class. If you want these slides, and eventually I'll add videos of this as well. Once we get the recording, I'll actually strip the recordings out and drop it onto these little sections. This goes to the learning management system that I use for classes that I teach. It should be free to register, so it should pop up a link that says register here. I just need username and password, sort of a thing. And that will get you access right now just to these slides and the basic information behind them. There's also some code that we're going to go through when we get to the lab section. That code is on GitHub. It's in an open repository, so you can get that directly as well. And that's basically some Ansible to help automate some of the tasks that we're going to talk about. All right? So I'll leave that up for just another second. Everybody get a picture of it? All right. So who am I? My name is Robert Starmer. I'm the CTO and founder of Cumulus Technologies. We're a systems consultancy. We help people build clouds. We also help people figure out what kind of clouds to build. And once they've built them, we can help you actually figure out how to use them appropriately. So really sort of a full service company. We've looked at tools from just bare metal management all the way through the sort of the full continuous deployment, continuous delivery type systems, and help people with that. Obviously, I'm on Twitter, so follow me on Twitter, tweet about the class. Cumulus Technologies is the company. They're also on Twitter. Two other things that might be useful. We do have a newsletter. We're just sort of restarting that. It sort of fell off for a couple months. But that newsletter is an area where I try to sort of highlight some of the latest things that happen in the cloud system space. The next one's actually going to go out on Monday. So if you haven't signed up, go ahead and sign up for our newsletter. There's also our 5 Minutes of Cloud YouTube channel. This is a channel that I use to sort of help people understand cloud, just in little 5 minute at a time snippets. So it's a pretty quick way to learn about some of the technologies that you might not have seen in the past. So an interesting area, and especially if you have like management staff that doesn't understand cloud very well, it's also a really good resource from them as well. So what are we going to talk about? We're going to talk about containers at a high level. What are they, how they fit into this space, and specifically why we're looking at using them. We're going to look at Ansible from the perspective of how it's being used in this particular environment, sort of as a tool for helping automate a deployment of OpenStack. And then we're going to look at the Kolla project, which is a tool that helps us automate the creation of containers around the OpenStack services and actually launching those containers as well. We're going to look at those three things. And lastly, for those of us that have some laptop access, we're actually going to try to do a deployment as well. All right. So out of this, why are we using containers? Why are we using containers for middleware? So why would we wrap OpenStack in a container? Why do we need idempotent configuration? I think hopefully for all of us that's very obvious. And what is Kolla and how do we actually launch it? All right. So that's step one. Any questions? All right, let's talk about some of the basics of containers. So what is a container? And other than what I've written up here, can anybody explain to me what a container is? This is interactive, by the way. You can talk back. I can hear you. So, no? Nobody's interested? It's an application bundle, right? It's a way of segregating a process from the rest of its systems peers. It's also a way of actually segregating network service, storage service, even the lower level interprocess communication resources. A container is a great way of bundling all these resources together. But when we talk about containers, often we sort of mix terms a little bit. There really are two key things that we talk about when we talk about a container. We talk about a container image. This is effectively the file system bundle that makes up the container, the process, and its local resources, the things it specifically needs to run. So often that's systems libraries or additional application components that are needed to actually launch that particular container. In addition to that, we then talk about a container as a running thing. This is the packaged state, the actual active running state of a process that is segregated from its peers within the environment. Right? So at a high level, that's what a container is. It's got a long history. Containers are not some new magical thing. They're really kind of new from the perspective of what Docker has done to the community. by simplifying the process of building containers, really more than anything else. But if we really wind the clock back, even in the 70s, we had the Chroot environment, which was a way of containerizing at least the file system and separating the file system from other file systems on the same machine, right? Jails in the FreeBSD world in 2000 provided the first Linux scale or Linux-like containerization, a way of actually looking at separating the process, or at the process level. Solaris Containers did the same thing for the Solaris operating system in 2004. In 2006, Google did this with Linux because they were trying to figure out how to start scaling their application environment. Only 11 short years ago, if you can imagine that. In 2007, they looked at this process model and they said, hey, we need more. We need more fine-grained control of how these processes are being segregated and the resources that they're consuming. And that's where the C groups model came up, right? We then saw LXC come on the scene, and that was a Google Canonical relationship where Canonical was trying to make it easier to actually bundle up all the resources and provide a management model for the container environment. So it was the first model for that. In 2013, after much complaint about how difficult it was to actually containerize these things, Google came up with a model of the tools called Let Me Contain That For You. Right? So let me take your application and put it into a container. It was still an LXC container at the time. And Docker came on the scene as well and said, well, we've got a different way of actually using some new technology, specifically the layered file system, to also create that container file system. So that really simplified things. And then the most recent thing, well, Rocket was in 2014, and actually Oracle just released one, I can't remember, Racecar or something like that, Racetrack, yet another runtime model for how to actually run these containers at the lowest level. Yes?
Basic question, I have problem to log in. We ask for user ID.
So there's another, right above that, there's a button on the web page. There's a button that says conference login.
Oh, okay.
And that just requests a single ID string, which is what you have.
Oh, thank you.
Yep. Okay. So what is a container? A container is really an efficient software delivery mechanism. And I think this is the thing that most people don't really get initially. If I'm going to containerize an application, what I'm really doing is simplifying how I deliver that application. I still have to write the app. I still have to figure out what its dependencies are. I have to work through all those dependencies. And finally, I want to actually deliver it and run it on an application environment. Well, if I run it in a containerized environment, then I'm bundling together all of its requirements into a simple package. Most of us that have done systems administration work realize that often when I deploy an application, there are a number of dependencies that are needed as well. And I have to install those dependencies separately. Well, in a container, I'm going to bundle all those dependencies together, right? So that's the #1 benefit of containerization, right? Once I've done that, as long as my host OS interface in the Linux world, that's basically the syscall interface, as long as that is consistent, I can take that containerized application in its runtime state and run it on any operating system that can support that interface. Right? The real benefit from a developer is that I can develop on my laptop, package up that container on my laptop, and then start running it in QA, running it in production. I don't have to reinstall every single time. And that's a huge benefit, a huge shift to how we actually think about this infrastructure. Right? Now, how does this apply to something like OpenStack? Well, OpenStack has a number of moving parts, a number of distributed resources. Right? And each one of those resources has its own set of dependencies. Now, for a specific release of OpenStack, right, like the Pike release that just closed its books today, right? For any one particular release, often the dependencies are consistent. Everybody's using the same version of 6. Everyone's using the same version of Parmico. All those resources are the same. But as soon as one of them changes and says, oh, well, I need to update one of my library dependencies, I potentially create an impact to any other application running on its system. So for those of us that have built bare metal OpenStack systems and have deployed the resources on that machine at the bare metal level, often a single installation will work fine. But if I try to upgrade even one piece of that, say I'm trying to even just develop an advanced version of a specific piece of that, often I run into version mismatch issues. And I have gone through so many times when I've blown up an entire OpenStack environment just because I tried to update one piece of that environment. Containerization fixes that, right? Because it segregates the process and its dependencies from all the others. And it does it in an application bundled sense. So we know there are a number of different resources when we talk about containers. Often people compare containers to virtual machines, and I think that's actually a false comparison. It's similar in a sense because I am thinking often about a virtual machine running a single process. But the reality is, I'm really thinking about those processes being segregated. And the Kubernetes world, if you guys start getting into that, that even takes it to the next level, because in the Kubernetes world, they don't even talk about a single container. They talk about a pod, which is multiple containers all working together. They're also sharing those same resources, namespace, storage space, et cetera. Right? So we can actually tie all these pieces together. So why do I want to use them? Often I can get to a small footprint. If I just need my application and its libraries, I don't need an operating system, so that saves me 200-300 megabytes in most cases. All right, so small disk image, right? I can actually limit what I'm putting into the system, and thereby reduce the overhead of that environment. Startup speed is one that we don't often think of. How long does it take to boot a server? An actual physical server, not like your laptop, but a real server. Anybody done it recently? 15, 20 minutes? Right? Especially if I put a terabyte of memory in it, it just takes forever. Right? If I boot a virtual machine that has a terabyte of memory allocated to it, 30 seconds to full operating system running. Right? Maybe even a little faster. I know I've seen some people really tune their operating system so you're booting in 15, 20 seconds. How long does it take to start a process? Microsecond? Less? Right? Containers are processes. Right? So when I launch a container, unless I have some startup processes that are going on within the container's already started though, often my container is able to start serving requests within a couple of microseconds. Right? Basically the time it takes to start a process within the environment. That's a completely different way of thinking about how your application works than when I have to include the fact that I need to boot the operating system before my application's running. Right? If I'm operating in an environment that is built on top of virtual machines, often I'm going to take time, many minutes, to actually launch that environment. Right? So I have to think about those minutes if I want to restart that environment. In the container world, there's a big shift because I go from taking many minutes to start an environment to microseconds. So as long as I have the container on disk, that's important. Right? I actually have to have the process ready to start. Right? If I type ls, I kick off the ls process, right? Well, in order to do that, if I had to download it from the internet first, I would have the internet download time to get ls to run every single time I tried to run it, right? So if I take that piece of the equation out of the way, I can launch the ls process in microseconds. I can launch Apache in microseconds, right? So that's a huge difference in how these things work. Scale up, scale down is dramatically simplified because I have quick start, I have small footprints, and I can pre-stage these resources as well. And the other thing, if I have a problem, I can start isolating it, I can start limiting it because it's just the container process itself that I'm limiting. Right? I can actually focus just on that one individual process rather than what's the rest of the operating system trying to do to me at the same time. Right? So I really have some real benefits there. And lastly, when I'm working with virtual machines in general, I actually have to understand how much resource I'm actually consuming because I'm locking up chunks of resource. And that's partially a scheduling issue more than the actual system level management issue. But I'm also often saying, hey, I'm going to give you one core. I might have a 40 core machine. I have no way of using those other 38 or 39 cores if I assign one core to my virtual machine. In the container space, if I don't define a cap, and I don't have a default cap built into my container management environment, I can potentially consume all 40 cores. I can also schedule things and provide scheduling resource management that says, well, I'd like to have at least a half a core available, but I'll use whatever you give me. All right, so suddenly the scheduling of resource becomes a little bit more efficient. That's why when people start talking about containerized data centers, they start talking about tens of thousands of containers rather than thousands of virtual machines.
Question.
Yeah.
So you say, in this case, suppose, let's say one container takes about, say, 10 cores, whatever it is, but later some other containers are coming, then they need to free up. So it's done dynamically and whether that.
So the containerization is a process, right? If you launch one process on a Linux operating system, it takes up how much of the system? Well, if it's multi-threaded, it can take every thread available, right? So it can take up to 40 threads in a 40-core machine, right? You launch another multi-threaded application, it gets a slice of that resource, right? Now, in the container world, we're basically modeling the resources as 1/1000th of a CPU slice. That's the minimum resource, a milli CPU, that you can allocate to or lock down to a particular container. Right? But in general, most people are not actually looking at resource scheduling. They're just scheduling their containers onto the system, any number of them. Right? And if your containers are not running full time all the time, then you actually get a nice sharing of all of your available resources. If you're doing big data workloads, that's probably not going to be true. Right? Because you're probably doing massive map reduce on your data set, and so while it's running, it's consuming all the resources it can get its hands on. Yeah, and they'll get a share, unless you have very specifically defined the resource allocation. You can provide a hard resource allocation or a soft resource allocation in the C group space, right? You can, I believe in Docker at least, and LXC, you can pin a CPU. Using higher level tools like Kubernetes, you lose some visibility into what you're doing. You basically get just a CPU allocation component currently. Yeah, but you can be pretty granular. Yes?
One thing comes to mind is security aspect. Security aspect of containers.
Yeah.
From the ecosystem, that's fine. But security is something.
Yeah, so there are some concerns about security, and I think you can think about it from a number of different perspectives. Sorry, and I keep stepping further forward. I keep forgetting. So the security aspect is multifold. If you're thinking about a multi-tenant environment where you have lots of different users on the same system sharing containers, there are some security concerns. However, the overall container community has been doing a lot of work in enabling a very locked down, very secure model. Now, there still is a shared syscall interface. It is still possible to write an application where if you haven't defined resource allocation limits, where you can basically lock up the system, right? Fork bombs still work because it's still a process, right? So I can consume all the available file descriptors, for example, in an environment pretty quickly. So there are some potential issues, but from an enterprise space, and especially from a middleware perspective, where I'm not necessarily going to share my containerized platform running my middleware with somebody else. All right, my interfaces are going to be web-centric interfaces, and as long as they're secured, then the system is secured at that level, right? I know that there are people that have done containerized applications that have passed PCI. Right? So there is at least a level of security there that the PCI community feels can address the security needs of an application. Right? Okay, so why would you not use containers? There are still some concerns or issues with how you deal with storage. Some tools like Kubernetes try to help address that, but it also defines specific storage engines that you might actually need sitting behind your environment, shared storage systems. So your NetApps, your Dateras, et cetera, right? Those sorts of systems. There are some challenges with networks with containers. At least the generic containerization model ends up effectively creating separated environments for the containers to run in and a mapping between that container shared environment and an external environment. So basically a NAT-like system. NAT-like setup is a fairly common environment. There are some L3-based container models as well, but looking at what the network does to your systems environment suddenly becomes a challenge, something that you have to consider. Right? Isolation from the kernel process. This sort of comes back to the security question. Is that isolation adequate for your applications and for your security requirements? Many people say yes, some say no, right? So it's something to be aware of. And yeah, you know, there are still some concerns. You know, the underlying operating system is now separated from your containerized environment. Who's keeping that secure? Is that secure enough? Because that's where your real security boundary still is. Right, the system that is running your container. And especially if you're running in a public environment, you don't have the control of that underlying resource. So it's just something to be aware of. Now, why is that important? Because I like OpenStack, and I think OpenStack should be under everything. No, I'm just saying. All right. So, basics of containers. Make sense? Good. I'm going to go through this fairly quickly. There's actually more here than I can really cover, especially if we're going to try to launch OpenStack in a containerized environment. And again, we're going to see exactly how we do that, if we can make it work for everybody. But yeah, let's talk a little bit about Ansible. Idempotent configuration. Does anybody know what idempotency means? At least from the perspective of running a task in an environment. Yes. If you run the same task, you get the same result, no matter how many times you do it. How many of you have written bash scripts to fix something in your system? How many of your systems administrators? That's maybe another question. Okay. So those of you that have run bash scripts know that writing a bash script over and over and over again maybe isn't the best thing to do. It's great to fix a problem, but unless you go in and you check everything that you've done before you do it again, you might blow up your system if you run it twice. Right? So bash is a very powerful tool, but is not normally an idempotent tool. Ansible, on the other hand, is. Right? And so we're going to talk about a number of the tools and the resources in Ansible, specifically because Kolla uses it to provide idempotent configuration for the Kolla deployed OpenStack environments. So once we containerize our environment, and we'll talk about how Kolla helps with that, once we containerize it, we'll actually then need to launch it. And when we launch it, we need to actually configure the resources that we're launching. So CAPS tools. CAPS is Chef, Ansible, Puppet, Salt, and I'm sure there are plenty of others as well. CF engines. I mean, I'm sure somebody will come up with one that I haven't thought of in a while. But these are the tools that people are talking about today that are idempotent, state-based configuration tools. The idea is that you define the state that you want to get the system to, and the tool will get you there, and then will keep you there. All right, some of them are run as agents, so they're basically constantly trying to keep your system in check. Ansible is one that often you run at a task basis. I would like to do something, I'd like to get the configuration to a certain state, run Ansible to accomplish that for us. But in all cases, we define the desired state, and we actually then can get to the target. Ansible is run from a Unix-like system, so Ansible currently does not run from a Windows machine. So if you want to run Ansible from a Windows machine, you need a local VM-like environment, or I guess with Windows 10 now, you get an Ubuntu Bash-like environment with Python, and that's what you need. Right? So maybe you can run Ansible from a Windows machine today. I've not done it, but challenge for one that wants to accept that. We describe our stateful sets as plays. Right? So I'm going to play a particular set, and that's going to end up giving me the state that I was looking for. Right? Within that play, we have tasks. Tasks define specific modules, so specific functions within the Ansible state system that provide state. Like, I'd like to copy a file and make sure that a file came from my local system to the remote system and has consistent state. Right? Inventory describes the targets for my resources. So one of the things that we need to do when we deploy OpenStack is we need to define our inventory. Where do we want our resources to go? Where do we want our state to exist? If we want to deploy Nova, the compute resource, which of our machines do we want to put Nova on? Right? If we want a three-way control plane, I need to have Galera running on my machines. But I also need to find some ordered state, so I'm going to define my first, second, and third controller so that I can actually turn on the Galera control plane. Right? And inventory does that for me. And lastly, in order to fix things, I'm going to modify and adjust variables. And actually, when we deploy Kolla for OpenStack, we have to modify at least a couple of variables. We need to know what network interfaces we're talking to. That has to be defined. Otherwise, we can't actually stand up the network environment. Right? The rest of it, then, is all done by agents. So we don't have too much configuration that we have to do. So here's an example of two modules. The user module, create a user on the system. Right? I don't have to go figure out if it's user add or add user or anything like that. I can just say user. Right? And then I define username, and I can define the state. Do I want it to exist or not exist? Right? And that's the sort of idempotent management. The default state is make this thing exist. But I can also make things not exist. Right? I want my state to be this user no longer exists, make him go away. Right? So the easiest little Ansible play to run is where I create a user or delete a user. Because that's system local.
So what are the values for the state?
Present, absent, I think latest. It depends to a certain extent on the module, but present and absent are almost always there. So that's state for a service. right? I don't have a restarted state for a user, right? But the service module has a special available state, right? And that's the equivalent of stop, and then again running a next task, which is to start it, right? One of the nice things about Ansible is that Ansible is very linear. And since most of us write scripts in a linear fashion, if we're taking something that was written in Bash or written in another scripting language, often it's very easy to translate that into Ansible and get the item potency that Ansible brings with its modules. Right? Inventory, like I said, is how I define how I get a hold of my system. Inventory has two components. The bare level resource, like Jumpy host, which also, actually I think this, the tag is now changed, but it's basically like this. I can either define hosts just by giving an IP address or a host name, and I'll assume some connection parameters that if I actually try to SSH to that target, I'll get there. In the case of Jumpy, for example, Jumpy does not do DNS resolution, so if I tried to do SSH to Jumpy, I wouldn't get there. Ansible wouldn't be able to get there either. So instead, I actually have to tell it, if I ask you to do something with host Jumpy, use this IP address instead. Right? So that's passing a variable to an inventory item.
So it doesn't take it from /etc?
It will take it from hosts. In this case, my point is that Jumpy doesn't exist in hosts, doesn't exist in DNS. Right? So I have to pass a specific address. Or maybe Jumpy has multiple addresses, and I want to use a specific interface. Right? So I have the ability to control how I communicate with it. I can also define, since I'm using SSH as my connection model, I can also define the user. I can define a bunch of information about that SSH connection to further refine how I communicate with my inventory devices.
Okay, what if you have unique password or password secure?
Well, the best way actually to do this, and the most common way, is to use SSH keys, public-private keys.
So you can add this in the
There are ways to add it in the playbook. If you don't already have communication with your host, though, it's very hard to get communication to set up your SSH keys without passing passwords, right?
So it's better to set it up.
Yeah, so if you're doing something with bare metal, often people will pre-establish or precede a public key that works. If you're doing this in a cloud environment, often you can use something like a cloud init tool to initialize an SSH key, a public key, so that you can actually get access as well, right? And as long as you have that initial access in the Ansible world, you can usually fix just about anything else. So for example, the Ubuntu 16.04 releases do not include Python. Ansible is a Python-based tool. Ansible needs Python to work. So there's actually a way to sort of bypass that by saying, hey, don't do anything except install Python. But there you really then suddenly have to know exactly what you're doing, and you want to make that script idempotent, because if I give you raw commands in Ansible, I bypass all of the Ansible benefits. Right? But I can fix things if they're not there. Jumpy is just a host, it's just a name, right? The idea is that what I have in this file is the description of the resources that I want, right? So for example, jump hosts might be something that I want to do something to every jump host that I have. Install an SSH key, install a specific package, maybe a VPN service, right? So I want to be able to separate them out. So I've put them in a grouping, jump hosts, right? Here I have web servers and databases, right? So those are separate machines that I might want to call out individually. There's also a grouping of all, which is do something to everybody, right? So I can also deal with all of my hosts at one time. Here I'm dealing with a group that is a group of groups, right? So I can say, hey, all my systems, which does not include my jump hosts, you can see they're not in here, but all my systems I actually want to do something to, right? So it's a way of further grouping things. And lastly, I can define hosts or variables. In this case, I'm defining an SSH user for all of my machines. So any machine I connect to, Ansible is going to try to connect as root, right? And again, this variable can match any of the other groups that I've defined, or even an individual host. Although usually at the individual host level, I'm just going to patch it directly onto the host name itself, right? So this means that the systems group is actually a group of children groups. So it has children, which are also groups. These are not expected to be host names, right? All right. So we've talked a little bit about inventory. We've looked at what a task kind of looks like. I can also differentiate machines when I'm running things at the level of actually launching an Ansible command. So this is running Ansible. It's telling it what module to run. So even without a playbook list, I can say, I want to run the setup command, right, which is a module. I want to read an inventory file, so I might still have a whole list of hosts, but I only want to use one host. I want to find one web server, or actually in this case a group of web servers, and get the output from those machines. Right? So I can target what I'm doing with Ansible. Where this becomes important is when I start thinking about building out a multi-node OpenStack environment with Kolla. I actually just need to start thinking about where my resources are going to go. Do I have specific machines that are just going to run my storage? Do I have specific machines that are going to manage my compute? Do I want compute on my controllers or not? All depends on how I'm actually implementing and deploying these resources. Right? So I can further tune my access because I can use those inventory groups. The other thing I can do, another powerful tool, and actually I need this, is that I can actually basically templatize and filter out specific resources. Now, one approach would be to say, well, I'll take all the configuration files for all of my different systems and create a template for them, and then I'll fill out the template and use that to configure Nova and Neutron and Keystone, etc. Right? And I have a very powerful set of tools, which is based on the Jinja 2 language, which is not too hard to learn. It's basically got some looping constructs and things of that nature. And that's another pretty powerful component. A real simple example is just taking something like the Ansible node name. So this is something that I could learn from that setup command, which would give me all of the facts the system knows about the remote machine, and replace in a web file the node name. And actually here I also look for the Linux release, right, and inject that into my environment. And here I get the default IP address, right? Finding those parameters is actually what that setup command that I listed earlier can help you with. Because if I run this command, I will actually get all of the lists of facts that the system knows at the start of an Ansible run. I can add facts, I can make facts up as I go, but that's the basic information that I would learn. Right? And then I can take that information, and I can drop it into a template like this, and now my web server that's running has a templated address. Now the other thing I can do is I can actually do conditionals as well. We're going to use conditionals because we're going to define exactly what resources we want on what machines based on conditionals. In fact, we're even going to define at a higher level what resources do we even want to run. Do we want to run Cinder or not? We don't need Cinder for an OpenStack environment to run, so we can decide if we want to turn that on or off. Right? And so we can use variables to define conditionals that then define what our system does. And that's just an example of filters. And lastly, like I said, we bundle all these things together in plays, and there's an even deeper version of this, which is roles, which means that I can actually start taking plays and grouping them together as things that I can apply on a machine-by-machine basis, rather than defining the full playbook for every machine that I want to use. So in this case, I'm going to look in my inventory and I'm going to find all my hosts. So that's easy. I'm just going to go and collapse the entire inventory list into just a set of host names. I'm going to apply that. I'm also going to make sure that I'm the root user because I want to run these application requests as the root user. They're the ones that he's the one who has access to this. Right? And lastly, our username is going to be present. Right? So here's the task that I'm going to then run. Right? So that's how Ansible works, in a sense. Right? Now, of course, I don't use the Ansible command for this. I use the Ansible Playbook command. That's an obvious one to know, right? You can say no. Great. And this is basically the same thing. I can actually, and this is kind of a funny one. So in YAML, 3- is a file separator. Right? So this is effectively 2 playbooks, and I could put this in one file. If I run this, what will happen is Ansible will log into all hosts and create the user Robert, and then Ansible will continue and run this task again, and it will make sure that Robert doesn't exist. So if I run this playbook, I create and delete Robert, and I leave the system in the same state as when I started, unless Robert existed before I started. Right? Anyway. So there's the power of Ansible. Let's talk about Kolla. or Kolla. So it is an OpenStack project. It is not one of the core projects. I'm sure you all know core projects. If you got kicked out of core, then you're very unhappy. Well, I don't think anything's ever really been kicked out of core at this point. There were some things that were pretty close, but not quite. So the idea with Kolla is it's a project that looks at and focuses on two, and actually now there's sort of a third version of it, three key functions within the OpenStack space. Firstly, there's the Kolla project, which is now the standalone Kolla project. Its whole focus is taking an OpenStack service and containerizing it. And it can deal with a couple of different aspects of the containerization process, including dealing with RPM or package-based, binary-based releases, or it can actually pull directly from an upstream source repository, either the OpenStack GitHub repository or Git repository, or even your local Git repository of the OpenStack code. It uses that to then build out containers. In addition to building out generic default containers, you can add additional resources in. There's a whole language for describing additional services and resources that you actually want to include in the containers that you build. This is most important if you're in the network service space and you actually want to include additional functions in the network space. In the storage space, there are specific storage plugins that would also potentially want to be mapped into, for example, the Cinder agent type environment to actually support functions there. So I actually kind of mentioned this briefly earlier. So if you're building OpenStack and you have a static environment, you're building, let's say, an Ekata system today, and you build it all from source on a set of machines, that's perfectly adequate and perfectly functional, right? If you then decide that Keystone needs to be updated, for example, because there's some new features that have just come out, often those updates also include changes to the libraries that Keystone needs. So when you update Keystone on your system, you break every other resource in your environment. That's the first thing. Yeah, so deployment simplification is the number one reason. If I have to restart a service, right, if I want to restart an entire environment, currently I basically have to stop the service and restart the service. And I can do that at the service level, so it looks very much like a containerized environment, right? Configuration also kind of gets mapped into this as well. I have efficient ways of managing the configuration files in the containerized environment, other than just leaving them on the flat file system, right? Yeah, so if there are dependencies and dependency have to be restarted, sure, they all map together. It makes it easier. That's the real benefit. Well, I mean, look, microservices may be an overloaded word as well, right? Yeah, certainly there are API-based services, but if you look at Nova is probably the microservice because it has an API interface and you don't have to deal with anything below the API interface to use Nova, right? Same is true for Neutron or Glance or Cinder, et cetera. Right? But the biggest benefit is that when you've containerized it, first off, you can actually upgrade resources much more quickly, potentially. Right? I mean, often there's still a database migration stage. That takes time. But restarting an older version of a container is actually a lot faster than rebuilding that process on the system. Right? So it's really a performance and management benefit. I see it becoming one. I don't know anybody who's deploying OpenStack today, at least that has built something new to deploy OpenStack today that hasn't containerized it first. I still see people that are working with non-containerized OpenStack environments, and their question is, how do I move to containerized environments? And really, the interesting thing there is I can stop the non-containerized process and launch a container to replace that process. So I can move to containers in a fairly manageable fashion even. Right? One of the things that the Kolla team has been testing is upgrades as well, upgrades and downgrades at a one version level. One of the big issues is that multi-version upgrades often break, but at least going from, for example, an Ekata deployed system to a Pike deployed system is something that the team is testing, and actually even just the OpenStack system in general is trying to test. How do I make sure that the database migrations work and database rollback works? Yes?
Since a lot of the core services are where each OpenStack service exposes a set of APIs, is it possible to upgrade, say, a specific service and maybe not the others? And then, because if they're communicating through the API,
Correct.
you could say potentially just upgrade Keystone.
Yeah, and that's the point. I've seen a lot of companies that say, hey, look, Keystone has a set of features that we need because it integrates better with our LDAP service or something along those lines. But Nova is doing exactly what we needed to do. We don't need to change Nova. Neutron, believe it or not, is working, so we're going to leave that, let that continue to remain stable. But we definitely want to change what we're doing in Keystone. Or we'd like to deploy a new service like Designate, right? So the DNS as a service component. We'd like to install and deploy that, but we don't want to change everything else. And if we're going to deploy it, we might as well deploy the latest. And it's often cases like that where you see the static, everything on one machine, manual configuration blow up. Right? Most people started dealing with this a couple of years back by deploying OpenStack services into separate VMs. Small VMs, sure, but each one got their own virtual machine space. Right? And then you ran into inefficiencies when Glance only gets impacted every once in a while, but it's still consuming 2 cores and 4 gig of memory out of your machine. Right? And again, containers help because they allow you to more equivalently manage the system. Eric.
So the opposite of what you're saying is I could get 6 hardware servers and run each one of the OpenStack services on separate hardware services, and then I would still have my ability to update any individual component.
Yeah, and then you want to add designates, and now you need a 7th server.
Yeah, then I just have
Yeah, and that's basically the VM model, right? So separated VM or separated bare metal.
So this way I can run everything on one machine, relatively cheaply, and still have the separation.
Yep, exactly. Okay. So when we look at the Kolla architecture, there are a number of components that we need. So there are the services themselves, and we're going to containerize those. In order to run Kolla, I need to have a container environment to run on top of. Kolla was built on the Docker model, so it uses Docker-based images. There is another model in the OpenStack community, the OpenStack Ansible project, maybe misnamed because it's really about using Ansible to create LXC and manage LXC-based containers. But in this case, we're using Docker, right? So Docker under the covers uses C groups and namespaces to segregate each of those containerized resources, right? Now, one of the things that I mentioned earlier in passing effectively, but I did mention that one of the issues that people have in most containerized environments is the network interaction. OpenStack networking is notoriously complex to begin with, right? Do I really want to layer a containerized networking service on top of that? Right? That's kind of a question. So in order to address that, most of the networking services within OpenStack actually do not use the container networking space, and they use host mode networking. Now what this really means is that the container effectively piggybacks on top of the host's network services. Right? It uses the network interfaces and port address space as well of those hosts. This works fairly well because the OpenStack community has already segregated its ports. It already sort of built on top of the model of saying, well, look, you know, Nova is going to be on port 8777, Neutron is going to be on port 8999. I can't remember them exactly, but you know, basically they're already separated at the port level. So it's okay that I share an IP address or an IP address space across all my containers.
But when you separate the container environment, so some components like Neutron has to interact with this controller. Still the same networking is provided by
Oh, so the actual underlying Neutron networking services, whether it talks to VLANs or VXLANs for tenant-based networking, mapping that to a virtual machine, all of that still is basically the underlying infrastructure doing its work. Managed by middleware, right? Neutron agent talking to Linux Bridge, or Neutron agent talking to Open Virtual Switch database. Right? OVS is still the engine that is configuring the local virtual network services.
So basically these containers are on top of
It's containerized Neutron service. So I have a Neutron API container. I have a Neutron server container, right? I have a Neutron OVS or Linux Bridge ML2 driver container. On the hosts that are running my virtual machines, I have a Neutron agent container that is specific to Linux Bridge or OVS or any other third-party based service as well. right? So I'm containerizing all of the management services. That's the middleware containerization. Eventually, I have an end effector, right? OVS manager, or I have libvirt. Actually, libvirt gets containerized too.
Because the reason is all the services you see in OVS container, those containers, but the host system will have to do the real process.
So the host system will have a OVS bridge that happens to be managed by a process that lives in a container, right? Because host bridging in a Linux machine is done in the kernel. The container is talking to the kernel. So the actual forwarding still happens in the kernel. Yeah. So actually, he had a question first, sorry.
Yeah, so when you're talking about if we containerize Nova, or like Nova, the controller, and you're containerizing the hypervisor, like libvirt, KVM, or KVMU. So if you actually instantiate a VM, and those are containerized, so the VMs will actually be running inside the container?
No. No. So what is libvirt? The libvirt process is really just, again, middleware that is configuring a process that's going to run on the kernel. Right? So it's going to manage a KVM instantiation. Right? The actual instantiation happens at the kernel level, outside of the container. The process to manage that is the libvirt binary that runs. And that's basically doing a translation from an API, the libvirt API, to what the kernel needs to know to actually launch that service. Right? Does that make sense?
Actually, I will defer the question later. The question is there are two networking infrastructure I am talking about. One is the networking infrastructure required for all the components of the OpenStack management it takes. Then after OpenStack is up running, you create network from as an OpenStack user, that is a transparent quality.
Yep.
So that means it creates all the OpenStack, neutron specific networking, which is like OVS project done. I assume that is different.
Yes.
And I have a question, later I come to that.
Well, but they're both containerized, right? So again, the Neutron server API was an API container, right? That is containerized. It uses host-based container networking. So basically, it gets the IP address of the host environment, right? And expresses port, whatever it is, 8997 or something like that, as its API endpoint, right? If then I say, okay, I'm going to go talk to the endpoint and say, hey, give me a network, right? Goes through the whole internals of Neutron to create the network, and eventually an agent somewhere says, oh, I have to have this network established on my infrastructure. I need a VLAN to be mapped to my port.
Okay.
Right, in the virtual space. So I'm going to talk to the virtual OVS database, which goes through a container,
Okay.
right? And in that container, the containerized open virtual switch agent talks to the kernel and updates the kernel data space to forward packets, right? Creating a new network if necessary, etc. Right?
Okay.
But all those services are at the container level.
Okay.
I have two questions here. One is when you're running Nova Compute, are you running, like when you deploy, are we deploying only one container per host, or is it multiple containers?
So if you run Nova Compute, the container that you're deploying is the Nova Compute agent container. Right? So you're deploying one container per Nova Compute target device, basically per hypervisor.
Okay.
Right? In the normal KVM-based hypervisor space.
Okay. That was my question. The second question is, so suppose end-to-end, like if you update any database and later if I happen to move that container to some other host, so how is that database,
So container databases, if you want a container to be able to move from host to host, if you wanted to take an application running a database on host A and move it to host B, what would you have to do? Either move the data with it or have a shared file system. And the same is true for containers. Containers are just processes. Yes, they're segregated from the rest of the system, but that doesn't make them magical.
no, let me ask you this way. So suppose I create, say, some users on OpenStack after I containerize this. So that will be stored in a database. Now, if I decide to move that container which stores the usernames, will the usernames, how is that handled?
So in most of the containers, the actual sort of target for the database is external to the container. So it's a volume mounted from the host. And what that means is that it is not a part of the container. If I delete the container, my data sticks around. Right? That's usually fairly important for database-like structures. Right? I could potentially create that container and store the data in the container itself. In order to do that, I would actually want a way to, and I have a mechanism within the Docker space at least, to say, hey, take this currently running image, which is basically an image on disk, it's been expanded onto disk, and bundle it back up, including any changes that occurred. It's fairly uncommon in the container space. Usually you think of containers as things that are fairly ephemeral. If they want persistence, you have persistence as a separate external storage volume. Right? So now if I want to take that container with its persistent external storage volume and move it to a different host, I can move the container image because that shouldn't have any persistence except maybe configuration, which also is usually external, right? Or managed by something like Ansible, which can make it consistent every time, right? And now I have to do something with that data. Either I already stored that data on a shared file system so I can just point to that shared file system location when I start the container up somewhere else, or I have to move that entire data set manually in some other fashion, right?
Managing all those, packaging into a image like Docker images. Is that the purpose of Kolla here? Or what is the Kolla purpose?
So Kolla creates this set of images, right? So I need a neutron container. Where am I going to get it from? Kolla does that. Oops. It uses it for the deployment, right? Now, it gets even better than that because the Kolla community has actually pushed a set of containers for, at least for Akata, I think actually Mitaka as well, has pushed a set of containers into the Docker Hub environment. So there's a full set of containers for, I think, a CentOS modeled system if you prefer CentOS modeled environments, and one for an Ubuntu modeled environment. Right? But it's also very easy to create your own. It just takes a little bit of time. Building the containers, my best efforts seem to be about 2 to 2.5 hours for the entire set of current OpenStack services that are supported by Kolla. And that's not just the core 6. Right? Kolla supports just about everything that's out there. Now, by supporting it, it means that it has containerized the processes and the services. Right? For example, I'm helping a customer deploy Trove. Trove did not containerize the Trove images that you need to actually run a Trove-based database. So you have to still build those yourself. Right? But the containers can be built by you. You can also build individual containers. Maybe you only want the core services stack. You can build just those individual containers. Right? I think we've actually talked through most of this. But there is the ability, like I said, to modify what you're building. And where this really comes into play is when you want specific versions of things or specific capabilities to be included either in the containers or in the configuration. In the environment that we're going to try to build in just a little bit, we're actually going to allow ourselves to modify the Nova compute model from KVM to QEMU, depending on the underlying resources that we're working on top of. So if you deploy Kolla on your laptop, for example, often you don't have nested virtualization turned on, and so you'd want QEMU to run. Right? But the container itself is built with this default model of thinking that you're going to be using KVM. So you want to be able to change that configuration, and you can do that through the build configuration. So I can either build the container in a specific way, or I can do that in post-deployment configuration as well. So I have a lot of flexibility in how I actually do that. There is an Ansible-based CLI. It's kind of interesting because it's really a Python wrapper around the Kolla Ansible CLI, or the Ansible Playbook CLI. And all that it's really doing is it's making sure that the right resources are being mapped to the Kolla environment when you're actually running Ansible. It also gives you a number of verbs, things that you can do within the Kolla space, like deploy and do pre-checks and redeploy. That's kind of an important one. Maybe I made a change, I added a service, and I want to get that mapped into my environment. I can actually use Kolla and Ansible to make sure the configuration is appropriate. So the one thing that's maybe still missing is that the Kolla Kubernetes, actually I think in Okata now this has pretty much been addressed, but some of the resiliency wasn't there. In the Mitaka-based environments, I know I had issues with some of the deployments.
Yeah, this is working?
I think it just died. Or?
Is it working? This Kolla.
Oh, the HA?
Yeah, the Kolla Kubernetes.
Kolla Kubernetes is, yes, it works. It does still have, at least in my view, some limitations in that it's not doing round-robin load balancing against the API endpoints. It picks one and uses that. But it does have a load balancer in front of it. So if that service disappears, the load balancer will flip over to the next service.
Because we tried to make it work in multi-node, we had a lot of problems.
In which release?
The latest
4.0?
We tried about 2 more, yeah, the latest one.
If you did it with the latest, if you did it from master, it should be working at this point.
Yeah.
I don't think the 4.0 Akata-based Kolla Kubernetes was working particularly well. I've
It's the
done,
latest OpenStack, yeah, not,
yeah, well, Akata is the latest still released one.
Correct.
Pike is coming, right? And they've been doing a lot of work on Kolla Kubernetes for Pike.
And even we couldn't make even the normal Kolla Ansible. For multi-node, we had problems, so we had to.
I do that all the time.
Yeah, but I posted him by issue, I didn't get it. Oh, I will talk after.
Yeah, we can talk after, but yeah, I mean, I do Kolla multi-node all the time, and that's, I've had controllers disappear and come back, and it works great. Right, so from my perspective, this is the most stable OpenStack system I've ever had, not the Kubernetes one, just the regular Kolla one at this point. Right. Do you guys know the Kubernetes? Yeah, sorry.
So if you have a set of machines with Kubernetes on it, and then you're also having the containerized OpenStack on it, so you're using the same infrastructure for container workloads directly, and
Yeah.
then OpenStack workloads like VM workloads. So the thing is, those workloads are being they're scheduled separately, right? But they're running on shared infrastructure. So
Yeah.
can you have like conflicts where you can since they're not talking to each other?
Well, so I think that the way I look at it is, you know, some people say, oh, well, I'll just have one Kubernetes infrastructure and I'll deploy OpenStack on top of it and I'll use that for VMs as well. I would suggest that you target specific machines for VM workloads and specific machines for Kubernetes workloads. I would even go so far as to taint your nodes that you want to run the OpenStack control plane on and just run the OpenStack control plane on those nodes.
Actually, the key motivation for us to explore this model is we need a requirement to have both container and the VMs on the same network so that they can communicate each other. Because some of our applications are already containerized,
Yeah.
some applications are VM, so we want that hybrid environment. We choose it. So my question, but I can defer the question, I don't know right time or not. The question is when I create VMs, which using Neutron, and when I create basically container, normal containers, either Kubernetes,
Yeah.
can coexist on the same network so that they can communicate.
They can. There are a couple of different models. Some of the cloud networks, Calico, Romana, Contiv, OpenContrail, even Nuage, I think. I'm probably missing somebody, I apologize. But all of those guys often have container and VM models so that Neutron can talk to the controller and create networks, and the whatever controller you're using for your container control plane can also talk to the same controller. All right, so then you're really using SDN to manage all of your network service, rather than just having one SDN for VMs, one SDN for containers. All right, so right now, if you deploy a generic Kubernetes environment and don't modify anything, you probably end up with, I think now it's Weave that they're using by default. All right, well, there's no Weave integration that I'm aware of for OpenStack directly, and so you would end up with two different environments if you used OpenStack to manage VMs and Kubernetes to manage containers, right?
That is our problem, when we need to find a solution to
Pick one network, not two. There's also a project called Courier, K-U-R-Y-R.
Yeah, we are experimenting that.
Right, so Courier is also trying to help sort of synchronize those system states.
Okay.
Right, and that would basically allow, basically it makes Neutron a CNI endpoint for Kubernetes,
Yeah.
right? Okay. Anyway, I'm not going to get into detail on Kubernetes. If people want to talk about that, we can talk about it later. I really kind of want to get to the lab, especially because I had my graphic artist create a cool icon for it, right? So when you say enroll, it'll ask you for a username and password, right? So what's your name, email, and confirm a password, right? And then you'll be at the same page. All right, and so most of this is what you already saw, right? So it's the slides, right? And then finally, oh yeah, if you log in, leave me a comment. I'd like to know what you think about the class. So then there's this last one, which is what we're just going to talk through. Where did I put it now? There we go. Okay, so in order to use Kolla, a couple things. You need to understand what the system itself needs. Under Kolla, like I was saying, our baseline is that we have to have Docker running. Right? Kolla doesn't run without Docker. I cannot build containers without having Docker installed. So the first thing we need to do is install Docker. So get.docker.com, I think, is the easiest way to do that. Right? The next thing I have to have is I have to have a Python environment. If I build this on an Ubuntu machine, then I have to install Python and a bunch of Python development libraries as well. Right? And again, these slides are all in the learning system. I need to install Ansible. I find the best way to install Ansible is via pip because the packaged versions are usually old. Unless you're on Red Hat, in which case you get the latest version, but usually it's kind of older, so I install Ansible via pip. And then lastly, I need the Kolla tools, and there are two ways of installing the Kolla tools. They are Python packages, so they are actually on PyPy, so you can install them with pip as well. Or you can actually clone the resources locally if you want the latest version, for example, or the top of tree version. And then you can install, again, via pip, but against the local directories. Right? And the generic instructions within the Kolla community are really good. They actually go through a lot of this as well. I've found that sometimes this gets a little bit tricky to remember how to do all these different steps, so I created a little bit of Ansible to do that for me, which is this, which I'm going to get to it a different way. So there's a lot of stuff on here, but the one that's I think most interesting is Kolla multinode. And again, this initialize Ansible. So now that you guys are Ansible experts, right, since we did a little micro Ansible training, you can start to read through this. But in reality, here is my hosts file. This is a little special, right, because what this is actually saying is I want to create a local set of SSH keys. I need SSH to be functional for Ansible to work. And since I'm going to run Ansible both from my local machine to my remote target, and then actually any of the machines within my multi-node environment also have to be able to be communicatable by Ansible because my Kolla deployment is going to do that. I'm going to create an SSH key that I'm just going to use for inter-site communication, inter-host communication. If you already have a model for doing this in your organization, do not copy mine. This is a cheesy way of doing it. It works for most of my labs, right? So this is just going through and doing some smartness. You know, I have things like when. This is that variable-based, should I do this stage or not kind of thing. But that's the first stage, is to do that. Then I want to, on all my hosts, I want to update a bunch of things. So I have there's clearly more advanced Ansible in here than otherwise. But really, I'm just doing a couple things. Updating my SSH keys. I have a separate task, so all the tasks just live in a different file for that. That's all that that's doing. I have a way to make sure that my host file is correct. Often the number one problem I've seen in deploying Kolla is that your hosts don't match. And the Rabbit message queue, which is a core part of OpenStack, I'm sure any of you that have deployed OpenStack have been hurt by Rabbit. But Rabbit is a tool that requires that your host names match. So if you tell it to go talk to IP address 12345, it says, I don't care, I want to know what host name that is. So as long as I can look up the host name, I'm fine. So there's a task just to make sure that your host IDs match what you said that they were in the Ansible scripts. Resolve.conf often is also somewhat broken in deployments I've found, so I have a way of cleaning that up at least a little bit to make sure that it's functional. Then I want to get a bunch of files up there. I've written some scripts to help automate the second stage. So once I have OpenStack running, if you guys have done this recently, you'll find that you have no flavors defined, you have no images, you probably don't have any networks available to you. You really have nothing but just the core OpenStack services. I find that's a kind of a useful state to get out of. So I've written some scripts to actually help that. I added a couple of basic default flavors. I set up some basic network ideas based on what I know the network looks like. I get an image from upstream. I have a script to delete nodes. That doesn't work very well. And then lastly, I have a launch script. The launch script is the, hey, let me make sure this thing works. Let me deploy a virtual machine and attach it to a network and give it a floating IP address. Right, so the generic model of OpenStack. So those scripts get uploaded. Then I create my inventory file. And this is the thing that's really the most important file other than what I actually want to deploy, which is the other really critical file in this system. The inventory file says which hosts in all of the virtual machines or the physical nodes that I deploy am I actually going to want to deploy particular services onto. So I've templatized that because I basically said, hey, look, I know which machines I'm building that are my controllers, and I know which machines I'm building that might be my compute or storage or whatever nodes. Those are systems that I would actually potentially initialize in slightly different ways. So my local Ansible inventory is going to even map to those particular machines, right? And then get the system up and running like that. This script does actually two functions. One is it makes sure it understands what the network environment looks like locally, assuming that it's configured correctly, and then also configures the global variables that are needed for Kolla to run, so it configures them properly. Then I have to install a bunch of packages, right? So I said I need to have a Python environment. Well, in order to install Ansible via pip, I also have to have a GCC environment, and I have to have SSL and FFI development support, et cetera, et cetera, et cetera. And so basically this entire stack is all based on that, right? Neutron client can go away now, finally, but you want the OpenStack clients probably if you want to actually do anything with your system, right? And I go through, do more configuration and updates. And lastly, I make sure that some of my key environments are actually correctly configured. And then I finally run this network script, which does some of that last stage configuration. All right, so that's my initialization script. That's what sets up the base environment. This doesn't run Kolla yet. Well, actually, that Debian script does run the passwords file. But this creates some of the basic resources. Right? So then I have to configure Kolla. I have to tell it where it's going to place things. I have to tell it what network it has. Right? What services do I want this system to deploy? Do I want Cinder? Do I want Swift? Do I want Glance backed by Swift? Right? And if I configure those things, I have to do that through two files. Specifically, it's the globals YAML file. This is the file that describes all of the top-level resources. The most important thing I have to configure in that file, though, beyond what services I do or don't want, because there is a default set that will get deployed if you don't do anything, I have to tell it what my public and my private networks are, or rather, my API-based network, in other words, how am I going to talk to OpenStack, and what is the network interface that I want to use for Neutron to take over. And as long as I tell it those two pieces of information, the system can run. In a multi-node environment, I do have to provide at least one more piece of information, which is what is the floating IP, the virtual IP that is going to be load balanced for all of my services. Right? In a multi-node environment, usually I'm going to deploy 3 controllers. Those 3 controllers need to have a load balancer sitting in front of them. And the system will actually deploy HA proxy for that function in a container.
So even if I have only one controller to start with, I need to.
If you expect to have multiple controllers, so if you want to start with one and then add over time, then you need to start acting as if it were a multi-controller environment from the very get-go, because you have to install the HA proxy service and you have to configure it that way. The reconfigure process, I don't think, is good enough to take a single non-HA controller-based environment and move it into a HA controller-based environment. If you set up a single node with the virtual IP on the network and you set the networks up correctly, then you can still deploy a single controller and then add the other 2 later. right? Because it will establish HA proxy. It says, well, I only have one target, one real IP behind this, but that's okay, right? And again, I've created a script to simplify some of that. Simplifies maybe an overstatement because it always gets tricky. But that's this one here. This works on Debian systems. I have done this in the past for CentOS, and I just get tired of trying to flip back and forth, so I've kind of stalled here. But basically, I'm looking, the reason I have multiple interfaces, so let's see, this is a VirtualBox environment, because it uses these addresses for 1604. Bond, I believe, is what I see in Packet.net machines. Have you guys seen Packet.net? Bare metal as a service, kind of useful sometimes. And anyway, and then Team, I think, was my DigitalOcean based environment. And of course, you could probably go even further, try this on Amazon. I'm sure you'll get a different set of network interfaces yet again. This goes through and it tries to figure out the neutron interface. Usually it's the second interface in the set. And then the IP address of my public interface. Right, so what interface am I actually using to talk to my OpenStack environment? So that's what all that mess is all about. And then it creates my globals file. Now this is a stripped down globals file, and in fact, there's a default that has a lot more information in it. Basically, a lot of stuff is commented out because a lot of it is already defaulted to something, but there are specific things that I want to make sure I'm doing. So here's where I'm sort of filling in, like I said, those critical key network resource pieces of information that has to be set. The rest of this, since I'm thinking about this as a single controller without HA, I turn off HA proxy, which actually automatically turns off keep alive D. And then I also want to make sure that the version of OpenStack that I'm installing is the one that I want to use. In this case, I'm saying I'm going to use Ubuntu, source-based, and the 4.0 release, which in this case particularly maps to Okada release, right? This, like I said, gets stacked onto the end of the globals file. I think in reality, I could just replace the globals file with this because these are the only parameters I have to set. And the system should run from that point. The other thing that has to happen, which actually this script doesn't do, is I have to create my, oh yeah, it does at the very bottom. I have to create my passwords. But the other thing I was saying, you know, if I'm going to run this in a virtual environment, I might not have nested virtualization, so I might not have the hardware model available to me. Right? And so in that case, here I'm actually looking at the machine to say, hey, do you have hardware virtualization available? If not, I'm going to modify my Kolla configuration in advance of even deploying Kolla. I have not turned Kolla on yet or haven't used it to launch the system. I'm going to add to my Nova compute configuration, so my compute nodes will say, hey, use QEMU instead of KVM for virtualization.
So what is the network interface and neutron external interface?
So network interface is effectively your API or management interface. Okay. That's an IP address, okay. Right? If you were going to have HA, you would need this interface plus a virtual IP on that network, okay. Right? On that network. The neutron interface is the external interface. That's where floating IP networks would normally get attached into your OpenStack environment.
For data traffic.
For data traffic, okay. Right? So the reason I would specify this is if on my machines that I'm running on, right, if I look and I see that I don't have VMX SVM or OXC0F in the CPU information output, if I don't have that in there, then I do not have a KVM hardware-based acceleration capable machine. So I'm probably running on a VM on my laptop. In which case I cannot use KVM, which was the default virtualization type. So in that case, I'm saying, hey, I want to reconfigure that when I launch Kolla to use the QEMU emulator. So that's my emulated, you know, para-virtualization sort of environment.
Yeah, but you need to specify
Only if you're on a non-hardware virtualized platform.
Oh, okay.
Right? And so this is basically creating an override file. Right? And the last thing I do is before I actually run my password generator, which actually I don't know why I don't do it in this script, but before I run my password generator, I like to have an admin password that I can remember rather than the variable, long, impossible to remember passwords that the system creates. So I just go in and I look for the Keystone admin password parameter in the passwords file and change it to something usable, at least memorable by me. Admin1 seems to be pretty memorable by me, but that means, of course, now all you guys know what my default password is. Bad security. Anyway, so that's the idea behind this script, right? So it sets up all the core things that we need in the Kolla environment. I think we're also at time, so I know that there's a little bit of networking that was being defined here. I'm going to go through the rest of these slides. You guys are obviously welcome to sit through this, but just wanted you to be aware of that too. So when we then want to configure it, like I said, we're going to modify those two files. And then finally, we're going to launch it. Now, before we launch it, the one thing that my scripts don't currently do is they don't generate the passwords. So the passwords, in this case, are all the passwords that all the systems need. So every database needs a password for its service. Every service has its own user account, needs a password. Right? And there's a script that goes through and generates all the passwords for all the possible services. It actually takes like a minute almost to run to generate them because it's trying to generate good random passwords. And that's why I overwrite the admin password so that I don't have to go and do it after this step. You can do it one way or the other, right? Once I've done that, I can actually skip this step in most cases because especially if I'm using my scripted environment, I know that I've done all the right things. That's why I scripted it. But there is a pre-checks command as well. So this is now running Kolla Ansible. That's not Ansible, but it is. This is a wrapper around the Ansible Playbook model, right? Reads this command and says, oh, you want to run the pre-check role. So I'm going to run a specific set of Ansible commands against my entire inventory file. All right, and actually, I think normally I'd also pass the specific inventory I want to use. Otherwise, it's just going to look for a file called inventory. All right, I'm going to run my pre-checks. That should hopefully complete cleanly and not complain about anything. If it complains about something, fix it, or your Kolla environment will not work. All right, and then lastly, I can run Kolla deploy, which is actually Kolla deploy. If I spell things, sometimes that helps. Right? So Kolla deploy, and that will then take, depending on network speed, whether or not you actually pre-built and have a local registry for your images, usually it takes about 15 to 20 minutes. At that point, you have a containerized OpenStack environment running. And the last thing that you can do is you can run my post install script if you want to use the model behind that. And again, we can just look at that real quick. So this script, again, goes and looks for the network interfaces because it needs to understand the network space that our external interface might be associated with. Tries to understand addresses, so it wants to actually pull out the administrative password out of the address file. And sets up an OpenRC file. So for those of you that worked with OpenStack, often you need a configuration file for your user and password, etc. In this case, it's creating an OpenRC file for the admin password or admin user and the admin project. And then it runs a couple of the other scripts, set up your network, set up your flavors, import an image, and actually it doesn't actually launch a system, so it tells you how to actually log into the user interface, the web UI within the environment. And that's it. With all of that, you have an OpenStack environment running. So, questions? Comments? Yes?
Could you talk, sorry, right, Blake, could you talk a little bit about upgrading from one OpenStack version to the next using this methodology?
Yeah, so the upgrade process is kind of interesting. Part of the upgrade process is a question of configuration and database migration. So there is actually a set of upgrade steps. So much like the here was the Kolla deploy and pre-checks stage, there is an upgrades stage as well. It assumes that you have now installed the updated version of the Kolla Ansible code. Right? So there's a different version of code for each of the different releases. And so you'd have to install that code because that probably has different, well, I guarantee you it has different Ansible for the different resources. But if you run the upgrade process, it actually tries to do all of the database migrations and then download and restart the containers with the upgraded code. And it manages that process stepwise. Right? There's also a downgrade process that I haven't personally tried, but supposedly works as well. Right? So you can go back to the previous version if you need to for some reason. Right? Other questions? Okay, yeah, we can talk right after this. The last thing that's included in that Git repository that's probably useful, if you guys haven't used Packet before, Packet or DigitalOcean or well, any of the online services, if you're just trying to get some of this launched, I have created a little Packet file. Obviously, you won't be able to use my project ID, so you'll want to change this parameter. But within Packet, this script will actually set up 2 nodes that you can then use. It will also create the inventory file for those 2 nodes. So that's the local inventory that my initialization script, for example, is looking for in order to launch that. And so it's creating a control device with Ubuntu 16.04 as the image. Oh, and this one didn't get updated. So this should have been a variable like this one here. Right? Project ID shouldn't be. That way you only have to change it once, not multiple times in the file. And it goes through and it actually tries to update the inventory to be correct for the control node, given whatever name you want to define for it. I also have, in this one, yes, I use dnsimple for DNS, so that way you can actually update your DNS records as well. Yes?
So right now, are we able to use Docker CE community?
Yes. Yes, Docker CE is actually what gets deployed by default.
The latest one?
Yeah. Which is, I think, 113 still?
17 or 4 or something.
Okay. Oh, well, it was version 1.13, but maybe they changed the name. But yeah, Docker CE is fine.
And other than OpenStack services, can we use Kolla?
So you can use the Kolla model for anything, but it's built around deploying and creating OpenStack containers and configuring OpenStack containers. There is, I don't know if it's very well documented, but there is a generic model for how to use the Kolla tools and to build yet another container. The idea is if somebody comes up with another OpenStack project, to incorporate that project into the Kolla deployment model. Right, but there's a lot of automation that's built around the model behind OpenStack rather than just generic, right? So it's not just a generic deployment tool set. Okay. All right. Thanks, guys.